Systems of linear equations. This is our first video. A linear system is made up of two or more linear equations. Solutions for a system, they must satisfy all of the equations in the system. Now, because the graph of a linear equation in two unknowns is a straight line, there are three possibilities of a system of two linear equations in two unknowns. One thing that they could do is that the lines could hit. So let me get some lines here. So I could have one line going that way, and I could possibly have another line coming this way. Let's move it a little bit. Yeah. So this particular point right here, where my little crosshairs is, that is a point that both of the lines have in common, and that would be a solution to the system. Well, another possibility. Let me borrow this line. What if the lines were parallel? Now, in order for you to have a solution, the lines have to hit. Well, parallel lines do not hit. So this type of situation would be no solution. Well, let's see another possibility. I'm going to borrow this line again. I think I'll move it though. I'm tired of that one. Yeah, let's make it going this way. Well, they hit. That's one possibility. They don't hit. That's another possibility. A third possibility. Let's see if I can get this. What if the lines were the exact same lines? And this thing's going to be stubborn. Let's see. I know. Let me see if I can go make that thing a little bit thicker. I can do this. Yeah. So if the one line is the very same equation as the other one, if you'll notice, they hit everywhere. So the solution set to this would be an infinite number of solutions because all the points are shared by both lines. So since we have three possibilities, then we can have three possible answers. One solution, like number 1, no solution because they're parallel lines, like number 2, or an infinite number of solutions, like number 3, because they're the same line. Now, to determine the solution to a system of linear equations, you need to graph both equations on the same axes. Think about this as saving graph paper. The point of intersection of the graphs gives us the solution. Well, now one thing that we can do, sometimes they'll give you a coordinate point and they want you to determine if that ordered pair is a solution to the system. So one thing I've got to do is substitute it in both and see if it works. So if I let x be 2 and y be 2, see if you can see this. 2 times 2 would be 4. 4 minus 2 would be 2. 2 equals 2. So that point works in that equation. Let's try it in the second one. 2 plus 3 times 2. Well, 2 plus, that would be 6. That would give me 8. 8 equals 8. So that coordinate point works in both of those equations. So in this particular situation, that would be a solution. Now, if you'll notice, I've got a question mark because I haven't made up my mind yet. But once I find out that 2 equals 2 and 8 equals 8, I know it's true. So yes, that ordered pair is a solution. Well, let's try 3 and 3 in this one. If I put 3 and 3 in that one, have my little question mark, I've got 3 minus 12. Well, that would give me a negative 9. So negative 9 equals negative 9. So it works in that one. Let's see about the other one. Let's see. This gives me a 9. This gives me 6. But now this is 9 minus 6. Well, 9 minus 6 does not equal 15. So this does not work. So this would not be a solution to the system. Another thing, let's see, determine the x and y intercepts and then graph the system on the same axes. State the solution, and if the system has no solution or if it's infinite solutions, we need to say so and state the reason why. Well, now, if you're not familiar with the x and y intercepts, I'd like you to get used to this because a lot of our word problems will end up looking like this, and this is a quick way to graph a linear equation. So if I let x be 0, if you sort of cover that up, can I get something to cover that up? Let's see, maybe I'll make a little box. Okay, so just pretend like this is 0. I think I might even put 0 in there. Will it let me? No. Oh well. We'll pretend like that's 0. Well, 0 plus y equals 6, y would have to equal 6. That's what intercepts are. You put 0 in for one value, and you find out what the other one has to be. So the point 0, 6, let me move my point, it would be right there. Well, let's put 0 in for y. So let me put 0. I don't sort of like that one. I know what I'll do. I think I will get a circle, but I'll make the circle look like 0. Yes. Okay. So now I've got x plus 0 equals 6, which would mean x would be 6. So I've got the point 6, 0. So let me move that one. I need to move it just a little bit. Now it's going to be easier for you to graph on yours, but I'll try. So let me get myself a straight line. Let me connect those 2 points. Not very well. That's not too bad. Alright, so that's that equation. So now in the next one, let's let x be 0. Now be careful here, because what I've got is a negative y equals 2, so that would mean y would equal negative 2. So that would mean the point 0, negative 2. So let me put them. It's so easier to do this by hand. Okay. So now I've got to let y be 0. And if I do that, x equals 2. So that would be that point. And it does look like these guys hit. That's not too bad. Let me get me a equation, my line again. See if I can connect. So it looks like they hit right there. That looks like the point, let me move my circle. Looks like the point 4, 2. So if you substitute in, 4 plus 2 gives you 6. 4 minus 2 gives you 2. So that is my solution. So you need to, in parentheses, somewhere indicate the intersection 4, 2, because that is your solution. Well, let's try this one. It was fortunate enough that this equation and this equation are the same. So the first one was 0, 6. The second one was 6, 0. I think, let me see if I can borrow this line. How convenient. Now the next one, I need to shorten this a little bit since I can't really see. There. So let's put 0 in for x. And if I do that, I've got negative y equals negative 5. Y would equal 5. So let me move my point to 0, 5. Now let me put my 0 in for y. Now I've got negative x equals negative 5, so that would mean x equals 5. Okay, I do think that they look parallel. So if you remember, my solution would be no solutions. They have to hit in order to have a solution. So we've got one more to do. So if I let x be 0, y equals 3. So let me get my point and put it on 0, 3. Not too bad. Let me get my y equals 0. That would be x equals negative 3. So let me put it on negative 3. Okay. Let's do the same here. When x is 0, I need to solve for y, so y would be 3. So it looks like that point and that point are the same. Oh, I didn't connect, did I? Well, Pooh Bear. Let me connect. See if I can go borrow this one. Move it just a little bit. I'll move this one down a little bit. That's good. Alright, so when I let x be 0 here, that term becomes 0. So I have negative 3y equals negative 9, or y equals 3. And then when I move 0 over to my y, I've got 3x equals negative 9. X would equal negative 3. And if I connect again, it would be the exact same line. So on this particular problem, my solution would be all real numbers, because these two equations are the same and they have the exact same coordinate points in common. So that's it for this video. Thank you.